Congratulations, you've made it to the Object-Oriented Programming Master Challenge. In this challenge, you're going to build a complete application using all the principles of object-oriented programming that we have covered in the last 2 sections of this course. The challenge is to write an application for a food restaurant. Let's start by finding out some details about the restaurant and what is required. Bill runs a fast food hamburger restaurant and sells hamburger meals. His meal orders are composed of 3 items: the hamburger, the drink, and the side item. Your challenge is to write an application to let Bill select the type of burgers and some of the additional items or extras that can be added to the burgers, as well as the actual pricing. You need a meal order. This should be composed of exactly 1 burger, 1 drink, and 1 side item. The most common meal order should be created without any arguments, like a regular burger, a small Coke, and fries, for example. You should be able to create other meal orders by specifying different burgers, drinks, and side items. You need a drink and side item. The drink should have at least a type, size, and price, and the price of the drink should change for each size. The side item needs at least a type and price. You need burgers. Every hamburger should have a burger type, a base price, and up to a maximum of 3 extra toppings. The constructor should include only the burger type and price. Extra toppings on a burger need to be added somehow and priced according to their type. The deluxe burger bonus. Create a deluxe burger meal with a deluxe burger that has a set price, so that any additional toppings do not change the price. The deluxe burger should have room for an additional 2 toppings. Your main method should have code to do the following. Create a default meal that uses the no arguments constructor. Create a meal with a burger and the drink and side item of your choice with up to 3 extra toppings. Create a meal with a deluxe burger where all items, drink, side item, and up to 5 extra toppings are included in the burger price. For each meal order, you'll want to perform these functions. Add some additional toppings to the burger, change the size of the drink, print the itemized list. This should include the price of the burger, any extra toppings, the drink price based on size, and the side item price. Print the total due amount for the meal. That's the challenge. I hope that makes sense. It's a bigger challenge than the ones you've seen so far in the course. You probably want to spend a bit of time working out your design on a piece of paper first. You'll want to do some work up front and decide how you want to build this application using some combination of composition, inheritance, encapsulation, and polymorphism techniques. Make sure you give this your best attempt and really try to have fun with it. The experience of doing this will be invaluable to you. Even partially completing this challenge will definitely help you get better at programming. Before you start the challenge, I just want to make it clear that it's very important that you've actually gone through the object-oriented programming sections of this course, specifically this section and the previous one. If you've skipped any videos, or if you don't understand the concepts of object-oriented programming, you might struggle with this challenge. The other thing to keep in mind is that there's lots of different ways of solving this challenge. I've purposely decided not to give you every parameter and method name, and I'm not telling you how to design your classes or relationships. The bottom line is, this is a challenge that's meant to test you and to really make you think. So see what you can do to figure this out and create your application. When you're ready, come back here and I'll work through my solution to the challenge. Pause the video now. Okay, how did you get on? Did you figure out a solution? Let's start with the diagram of my design. This diagram doesn't include the deluxe burger class. We'll look at that a bit later. In my solution, the meal order class uses composition in the design. It's composed of a burger as well as a drink and a side, which will just be items. These are all really items, although I specialize the burger class. I've used inheritance for the item and burger relationships, which means burger is an item. Every item has a name, type, price or base price, and a size. Item has the method, getBasePrice, which is really just a getter method for the price, but the name is more descriptive. Item also has getAdjustedPrice and the printItem method. These methods will exhibit different behavior based on the runtime type, and we know that's polymorphism. For the burger, the toppings or extras are individual attributes and also have the type item. I'm going to use the meal order class to hide some of the implementation details from the calling code. This means I'm going to use encapsulation techniques on meal order and item. The meal order class has additional methods that will delegate work to some of its parts, meaning the calling code won't interact directly with any of the parts. This is just one way to do this. one way of many possible solutions. Okay, let's get started. I've already created a project called Bill's Burger Challenge and created the main class and main method. But I'm going to start with the base class for most of my classes, the item. So let's create that. I'll add the item's fields. Private string type, private string name, private double price. Private string size equals the string literal medium. Here I have type. This will be burger, drink, side or topping, for example. Name and price, and that price will be the base price. Then I've also got size here, and I've said it has the type of string, and for this I'm going to set the default value to medium. Now that I have the fields, I can add a constructor. I'll include all the fields except size. And I want to just change the constructor to make both the type and name of the item uppercase. I could add validation here as well, but for simplicity's sake, I'll leave that out. But you might want to check if the type is a valid type, for example, or whatever kind of validation makes sense. And I'll also add getters for the name and price fields. And just for more clarity, I want the name of that getter, getPrice, to actually be getBasePrice. And let's change the code in getName to include the size of the item. If parentheses type dot equals literal string, side in uppercase, or type dot equals, and the argument, a literal string, drink in uppercase and closing parentheses. Return size plus a string literal containing a space plus name. In this code, I'm saying if the type is a side or drink, and remember I made the type uppercase in the constructor, I'll also print out the size, which I'm expecting to be small, medium or large. Next, I need a method to get the adjusted price of an item. And because I am not subclassing the item class except for burgers, I want to customize what happens for the other types in this method. Public double, get adjusted price. Return, switch, size, left curly brace. Case, literal string, small in uppercase. Switch expression arrow, a call to get base price minus 0.5. Case, literal string, large in uppercase. Switch expression arrow, a call to get base price plus 1. Default, switch expression arrow, a call to get base price. Right curly brace, semicolon. This code adjusts pricing for drinks and sides. I'll make both the sides and drinks have the same price adjustments for simplicity. Okay, so if something is small, I'll subtract 50 cents from it, but if it's large, I'll add $1. And the default value ensures a medium drink or side gets no adjustment to its price. And one other thing I want is a setter for the size attribute. I want Bob's employees to be able to adjust the size of a drink on a meal. I'll add a setter for size. And finally, let's create a method to print the item name and the item's price, meaning the adjusted price. I want everything to be printed out, all the items, the burger, its toppings, and the subtotals and totals to be printed out in a uniform way. First, I'm going to create a static method on this class and use a format string so that any code can call this method, passing a label and price, and it'll get formatted the same. Public static void print item, and the parameters are string name and double price. I'll use printf with formatting for the name and price. Okay, what's this code going to do? I'm formatting a string literal that may look a bit different than what you've seen before. This string has 2 specifiers, but here I'm including some optional features with the specifiers. The %s is for a string, meaning it will get replaced by a string variable, but I can specify how wide I want the string to be by putting a number between the % and the s. Here I'm reserving 20 characters for the first argument, and I'll just pass the name to that. And the second specifier is %f for a floating point number, but again I've inserted some options between the % and the f. In this case, I'm saying I want 6 characters up to the decimal point, which includes spaces and numbers, and I want a precision of 2, meaning I want 2 decimal places. Right, so this method can be called from anywhere. Next, I'll create an instance method with the same name, but no arguments on the item class, and this will just call the static method. Public void print item, and the arguments will be 2 method calls, the first to get name, and the second to get adjusted price. These are the methods that will get overridden for any subclasses, and I can test this in the main method. Item Coke equals new item, and the arguments I'll pass are 2 string literals, drink and Coke, and then $1.50 for the price. Coke.printItem, Coke.setSize, and the string literal large. Coke.printItem, and this creates a drink that's a Coke with a base price of $1.50. This is the price of the medium drink, the way I have it coded. I print that, but next I set the size of the drink to large, and then I print that. And if I run that, I see a medium Coke printed for $1.50 and a large Coke for $2.50. You can see that the items got aligned nicely because of the format string I used, and we can see the price adjusted accordingly also. And let's test out a topping. Item avocado equals new item, and the two string literal arguments topping and avocado, and the price of $1.50 again. Avocado.printItem. And running that, you can see the third line item, avocado, and that's lined up like the other items. Okay, that's the item class. In the next video, I'll create the burger class, the meal order class, and then specialize the burger. I'll see you in that next video.